Yes, sir.
See, for example, if you are designing a slider, so basically, see here, you are designing a slider. Like, so why you are designing the slider? First question is that why do you are designing the slider? Because you have an external undercut into the component, right? And here you can see that this is nothing but this will become the cavity. This is the complete cavity. So basically, you have to prepare the slider from here. 1 minute. You have to prepare the slider from here, right or wrong? So that's why slider is nothing but it is the part of the cavity, right?
Yes.
Okay, now if I'm talking about the lifter is the part of the core. Why? Because internal feature is here, right? So we have to prepare a
Lifter.
lifter pin, which is also known as a form pin. Now this is the core plate. See, this is the core plate. Here you can see that this is the core. So lifter is nothing but it is the part of the core. So we have to subtract or the split this portion from the core, right? That's why we have to we can create the lifter pin. Okay, understood? See here. Okay, so lifter is nothing but it is known as form pin, है ना? From the core side of the part in mold. Okay, in order to eject the part without deformation or the defect. Why it is used? Because we have to eject the part without deformation. Because of the internal feature, there that can be a deformation during the ejection, right? So that's why, in order to eject the component without deformation or without defect, we have to provide the lifter pin. See here, in this component, you can see the internal feature, right? Now, right now, if I am ejecting the component, what will happen here?
It will not come out.
Right? It will come out, but component will be break. Component will be break. Or sometime, for example, if your internal feature length, you can say that the internal feature size or the length is like 1 mm, and if you want to eject the component into 1 mm, so basically this feature will create the scratch into the internal surface of the part, right?
Correct.
Because what I have tell you about the jumping out process, what I have been tell you, jumping out, for the jumping out process there is a condition there, right? What is the condition? That it should be radius. It should be radius first of all, and how much radius it should be? 0.5. 0.5 or less than 0.5, or material should be flexible like PP or POM or PA, so we can use jumping out process. But here, for example, if the undercut is more than 0.5 and it has a sharp edges like these, undercut, right? I am talking about the undercut. Okay, so we cannot use the jumping out process, right? So that's why we have to use the mechanism. So here we cannot eject the component right now. So ejection is not possible here. Okay, so here you can see that this is the internal feature. For that, we have to use a lifter pin or the form pin. See, so this is the same replica of that feature, right? This form pin has the same replica of that feature. Understood?
Yes.
Okay, so here see, this is nothing but this is the center line or the center axis of the lifter pin. Okay, or this is the center axis of the mold. Okay, so this should be an angle. Okay, so between this axis and between this axis there should be an angle. Why? What is the reason of this angle? Because of this angle, if I'm giving the direction to this axis, right? So basically it will release the undercut, and as well as it will eject the component also. See, this angle is very important. Is it clear? See here. Okay, so here you can see that this is the undercut. So basically, what movement we need? how much movement we need for the lifter pin, which will be the stroke, and what is the stroke? Undercut plus clearance. Yesterday we have discussed about the for the slider. Right now we are discussing about the stroke for the lifter, right? So this is nothing but this is the stroke, right? And what is this?
Clearance.
Clearance, which is very important, right? Clearance. Okay, see, so clearance is depending upon the space available. For example, you have a component, right? Now see here, for example, you have a component like this, okay, and you have an internal undercut in this component which is like this, see here, okay. And for example, you have a rib and gussets into this component like this, rib and gussets, okay. So for example, if you are designing a lifter here, you are designing a lifter, for example, this is the lifter, right? Okay, so how much movement you can provide here? Only this, right? You cannot move this lifter more than this distance, right or wrong?
Yes.
Yes, if you provide the distance more than this distance, if you slide this lifter more than this distance, so what will happen there? This feature will be break. Okay, this feature will be break. Right? Okay, so basically there is a limit. There is a limit for the clearance, and there is a limit for designing the lifter also, lifter pin also. Okay, but if I'm talking about the external feature, so for the external feature there is a limit or not? No, there is no limit. But we should take, however we should take the minimum clearance. Okay, we can take 2 to 3 or the maximum 5 mm clearance. We cannot take the clearance about 15 mm to 20 mm, right or wrong? Because there is no requirement for that.
Correct.
We have no requirement about the 15 or the 20, but minimum distance we should take there. But here we have a limitation. But in the lifter we have a limitation. Okay. See here, the stroke is nothing but undercut plus clearance. Understood? See here. Now, okay, I am inserting the lifter into the mold. See here. So basically, I am just showing a few component of the mold. See here. What is this is the core plate. What is this? This is the ejector grid. Ejector grid is nothing but it is the combination of ejector plate and ejector back plate, right? Ejector grid, it is the combination of ejector plate and ejector back plate, right? Okay, now you can see that this is the core plate here, and this is nothing but this is the ejector grid. So here you can see that lifter pin will be attached with this ejector plate or ejector grid, right? So basically, movement of this lifter pin is 1 minute. Ejector grid movement is responsible for the movement of the ejector pin. Lifter pin, right?
Lifter pin. Yes.
Okay. So here you can see that depending upon this length, how much is the ejection stroke. Okay, depending upon this stroke, okay, this movement is responsible. This movement, which is the horizontal movement, you can say that, right? Depending upon this distance. Understood? Okay, now see here. So we can calculate this distance with this ejection stroke by preparing the mold base. We find out this distance, right?
Yes.
Okay. How?
Yes.
How? Tell me.
Depends on thickness of the height of the part.
Height of the part, right? For example, if the component height is about 30 mm, so what distance we can take for this?
30 plus clearance.
30 plus clearance. So 30 plus 10 mm I can take. 30 plus 10 mm I can take, right? But for example, if I'm using a return pin, what I'm using? Return pin. So for the return pin, I have to use a spring also. So sometime I have to take 15 or the 20 mm clearance, because there will be a spring here. Because there will be a spring also, right? Understood?
Yes, sir.
Okay, sometime we have to take. Okay. Okay, now see the movement. See, this is the component, this is the core plate, this is the ejector plate or ejector back plate, or this is the lifter pin, which is also known as form pin. Okay, now see the movement, how it is working. See, basically the lifter has two movement. One is the horizontal movement and one is the vertical movement. Vertical movement by the ejector grid. See, but here you can see that. Here you can see that, for example, if this is moving in horizontal direction, okay, because of this angle, है ना? So basically, if this point is moving, so basically this point also will be moved, right? See, this point is moving or not? This point, and see this point. This point is moving or not? See.
Yes, it's moving.
Yes, so it means we have to give the guide rail here also. So we have to give the clearance here also for the movement, for the proper movement, because this is not the flexible part. This is not the this is the rod, or this is nothing but this is the complete component, right? Okay, this is the rigid component, you can say that. So basically this is not the flexible like a sheet or like you can say that like a strip. This is not like a strip, right? This is the rigid component of MS or the C45 which we are using, right? So that's why if this is moving here, so that's why it will be moved here also. So that's why we have to take the clearance here also. So we have to provide the guide rail. Understood?
Yes.
Okay. Guide rail into
Is
the,
the angle is fixed or not, sir?
sorry, yeah, angle will be
Is that
fixed.
And fixed or is depends on component or it's fixed?
It will be fixed, but we have to calculate the angle depending upon the stroke and the how much ejector stroke we need. So depending upon the ejector stroke, है ना, and the what stroke we required here. So depending upon these two distance or this two parameter, we have to calculate the proper angle.
Okay. Is there any particular formula?
Yes. See here. See simple trigonometry. See here. See. Okay. So you understood about this mechanism? See.
Yes.
Okay. So here, what is the important thing here? Ejection stroke. है ना? So ejection stroke we can find out by making the mold base. Okay. By making the mold base. And we all know how to prepare the mold base, how to decide the length and width, how to decide the height of the mold. Depending upon that, we have to decide the ejection stroke, right? Okay, now see the process of design lifter mechanism. Okay, first of all, we have to design or we have to take the complete layout of the single or the multi-cavity. For example, if we are dealing with the single or the multi-cavity, we have to prepare the layout for that. Okay, then prepare a complete kit design of mold base. Okay, then depending upon the condition, for example, if we have a component and component has an undercut, for example, if 3 mm undercut, so depending upon the condition, we have to take the stroke and the ejection stroke. Depending upon these two parameter, we have to calculate the angle. Understood? Okay, see, so this angle should not be more than 15 degree. Achha, what is the reason of that? What is the reason of this? That angle should not be more than 15 degree. Depending upon the length. Now, see here. For example, if I am talking about this, see. So here you can see that from this point to this point, there is a large length, right or wrong? Okay, this is the much length, you can say that, right? For example, its length is about see, ejection stroke about 40, and this distance is about to, for example, 40, and this is again about to 40. Okay, for example, okay, so here you can see that what is the height or what is the length of the lifter here? About 120 mm, right or wrong? Or more than 120, right or wrong? If I am taking one more plate here, back plate, so more than it can be 150 mm. So because of the higher length, we have to take the minimum angle, right? So because of maximum we can take 15 degree. Maximum we can take 15 degree. Understood?
Yes.
Okay. Now see here. See. Okay. Now angle calculation for the lifter. So it is depending upon two things, which is the stroke and the ejection movement again. है ना? Stroke and the ejection movement. So stroke is nothing but it is the undercut plus clearance, and ejection movement we can find out from the mold based design, right? Now see here. Again see here. As I told you that it is depending upon two things, stroke and the ejection movement. So here we need this stroke, right? We need this stroke, and we have this ejection movement. So basically we have to find out the angle, right? A simple trigonometry. See here. So for example, if we have a now see the example. Okay, for example, if we have a internal undercut about 3 mm and the ejection stroke is about 35 mm, okay, then what will be the lifter pin angle? And here we have a condition also, that not lifter pin cannot move more than 6 mm. Lifter pin cannot move more than 6 mm. What is the meaning of this sentence? What is the meaning of this note?
It may affect the other features also.
Yes, other feature, or maybe lifter pin can be touched with the another lifter pin. For example, if a component has undercut here and here also. So basically, if we are using two lifter, so basically both can be touch to each other. Okay, if they will touch, it means they can be damaged also. Right. The lifter pin cannot move more than 6 mm. Is it clear? This is the note. Now see here. Given data is undercut is the 3 mm. Ejection stroke is 35 mm. Just for an example, I am taking the ejection stroke. Okay. Now stroke will be 3 mm plus 2 mm clearance I am taking. Why? Because here in example it is showing that lifter pin cannot move more than 6 mm. That's why I am taking clearance only 2 mm. Or what is the undercut length? 3 mm. So total will be the stroke 5 mm we need. 5 mm we can take, right? So use the trigonometry angle. Angle will be 8.13. How? See, this is the 5 mm. This is the 35 mm. What is this? This is the perpendicular. This will be the base. We need this angle. So by the tan theta, P upon me, B, perpendicular upon me, base, theta equal to tan inverse, right? Calculate the angle.
Yes,
So you will get this angle, which is the 8.13. So how much angle we should take?
you can take 10 degree.
By? See here. Again see here. Lifter pin cannot move more than 6 mm. For example, if you are taking the higher degree, है ना? For example, if you are taking the 10 degree. Now, what happen here? See.
It will move more than 6 mm.
Yes. Okay. So because of this, maybe it can move 6.5. If it is move 6.5, it means it will break the another feature. So if you are calculating 1.3, 8.13, so you have to take the minimum, which is the 8 degree. Is it clear?
Yes.
Understood?